So let's look at another example here on the trapezium rule, the trapezoidal method. We are given plot a graph of y equals to 6 over x for values of x from 2 to 4. Then estimate the area bounded by the curve, that is y equals to 6 over x, the x-axis, and the lines x equals to 2 and x equals to 4. Using part A, we need to use 4 trapezium. Then part B, we use 3 ordinates. So in this case, first we need to plot this on a graph, but I'll just do a sketch. We have the function y equals to 6 over x. Then for values of x equals to 2 to x equals to 4. And the value of y when x is 2, 6 divided by 2, that will be 3. 6 divided by 3, that will be 2. And 6 divided by 4, that will give us 1.5. If I do a sketch here, then 2 corresponding to 3, that is, then we have the point 3, 2, and the point 4, 1.5. So this will be the curve. This is the curve of y equals to 6 over x. And then we need the region bounded by that curve, the x-axis, and the lines x equals to 2. So this is the line x equals to 2. And this is the line x equals to 4. So this is the area that we need. And on the lower side, we have the x-axis, the area of this region. So for part A, we need to use 4 trapezia. Remember, 4 trapezia means that we are going to use 5 ordinates. We will be using 5 ordinates. And it is for values of x from 2 to 4. Therefore, the length there is 4 minus 2. Therefore, we have 2 units. So the first thing we need to get is what will be the height of one trapezium. Therefore, we have 2 units and we need 4 trapeziums. Therefore, we'll have a height of 0.5. So we go ahead and divide that. So from 2, then up to 2.5, the height of 0.5. So here we'll have 2.5. Then 2.5 to 3, we get our second trapezium. Then 3 to 3.5, we get our third trapezium. And finally 3.5 to 4. So you have 1, 2, 3, 4 trapeziums. Therefore we'll have the ordinates, the first one, the second one, the third one, the fourth one, and the fifth one. Therefore we need to get the values of all these. On a graph, I would have read the values direct, but in this situation, I will get those ordinates. That is the first ordinate, the second ordinate, y1, y2, y3, y4. That is the 5 ordinates. Please note, the first ordinate corresponds to the value of x is 2. And when x equals to 2, remember, the value of y is 6 over x. So when x is 2, then y will be 3. The second ordinate, y1, is when x is 2.5. So that y1 will be 6 divided by 2.5 to give us 2.4. The third y is when x is 3. Therefore, 6 divided by 3, that will be 2. Then the second ordinate is when x is 3.5, then the value of y there will be 6 divided by 3.5 to give us 1.7143. And finally, when x is 4, the y ordinate there, the fifth ordinate will be 6 divided by 4, which is 1.5. Then we go ahead and calculate the area, which will be a half h into the first ordinate plus the last ordinate plus twice the ordinates in between, which is y1 plus y2 plus y3. All that multiplied by a half h. Our height, we noted, is 0.5 into the first ordinate, which is 3, plus the last ordinate, which is 1.5, plus twice the second ordinate here, 2.4, plus 2 plus 1.7143. And this is a half times, note that 0.5 is a half, into 3 plus 1.5, we need to close that bracket, 3 plus 1.5, that is 4.5, plus twice into, we total this, that is 2.4 plus 2 plus 1.7143 to give us 6.1143. And when we multiply that by 2, then we add 4.5, then we multiply by a quarter. That gives us an area of 4.18215 square units, which we can write to 4 decimal places or 4 significant figures. If it was 4 significant figures, we could give it as 4.182 square units. But in this case, we'll go for 4 decimal places so that we have a higher accuracy. Then we give it as 4.1822 square units. So in this case, we have used 4 trapezia and we have used 5 ordinates. Let's look at a situation where by now we need to use 3 ordinates. So we've seen when we use the 4 trapezia, the 5 ordinates, we are getting the area as 4.1822 square units. What if now we need to use 3 ordinates? Remember we are saying when you have 3 ordinates, then those are boundaries of 2 trapezia. So using 3 ordinates could also be asked. It's simply asking us to use 2 trapezia. We've seen when we have used 4 trapezia, we have used 5 ordinates. Always note that the number of trapeziums is 1 less than the number of ordinates, or the other way around. The number of ordinates is 1 more than the number of trapezia. Therefore, we go and check what is the length. The length at the base there is, we need x equals to 2 up to x equals to 4. So that is 4 minus 2, therefore that is 2 units. So what will be our height h? our height will be the 2 units divided by the number of trapeziums that we need, divided by 2. Therefore, we'll have a height of 1 unit. So from 1 unit will be 2 to 3. So our second ordinate will be there, then 3 to 4. So this will be our 2 trapeziums. So we'll have the first ordinate, the second ordinate, and the third ordinate. And in this case, now we go ahead to a half h into the first ordinate plus the last ordinate plus twice all the ordinates in between. And in this case, because there are 3, it's only 1 ordinate that is in between. So that we'll have a half of our height is 1 unit into y naught. This is the value of y when x is 2, which we had calculated and found it will be 3 plus the last ordinate there when x is 4, which is 1.5 plus twice the ordinate in between when x is 3, and we found the value of y there is 2. And that gives us a half of 3 plus 1.5, that gives us 4.5 plus 2 times 2 to give us 4, and this will be 8.5 divided by 2, which is 4.25 square units. You notice there is a difference when we used 4 trapezia or 5 ordinates, 4.1822. When we use 3 ordinates or 2 trapezia, we are getting 4.25 square units. Meaning that, remember, this is an estimation, and the smaller the size of the trapezia used, the higher the accuracy. We can't get the accurate value, but the value gets closer to the actual area of this region. So that is it. That will be 4.25 square units when we use 3 ordinates, and 4.1822 when we use 4 trapezia. I'll be sending some questions to you, which you'll try to solve using the trapezium rule and see how much you've understood on the trapezium rule. Till then, have a nice time.